In this video, we're going to go through pH and solubility. We're going to answer the essential question, how does changing pH affect the solubility of a salt? So the solubility of a salt can increase or decrease depending on the pH of the solution. Now this effect is especially noticeable when the salt contains a weak acid, weak base, or hydroxide ion as part of its makeup. So if the salt contains a weak acid anion, adding an acid is going to lower the pH and it will increase solubility. So let's look at this example. We have sodium fluoride. So sodium fluoride, when it dissolves, you've got sodium fluoride, it's a solid, and it would dissociate into sodium ions and fluorine ions. Okay, now if I add H to our solution, if I add hydrogen to our solution, that would be coming from an acid. Hydrogen is positive, and opposites attract, so it's going to want to come in here and scoop up those fluorine ions to form HF. So the other reaction that we're going to have is H plus is going to combine with F minus to form HF. Okay, so by doing this, it's going to remove fluorine from the system. And the saying that we have with Le Châtelier's principle is add, shift, away. So if I'm adding or increasing my concentration, it is going to shift that direction. Here we have the opposite thing happening. So if I were increasing the concentration of fluorine, it would shift away. But since I'm removing fluorine from the system, since hydrogen is coming in here and it's combining with fluorine, it's going to shift towards that deficiency or what's being removed from the system. So it would shift to the right here. And in doing so, it's going to increase solubility. So this is undissolved, and then this is dissolved in solution. So by shifting towards the ions where it's dissolved, that means that solubility increases here. Let's look at another example. If the salt contains a weak base cation, adding a base or raising the pH is going to increase solubility. So again, we've got an example here. We have NH₄Cl, so ammonium chloride, and that is a solid, and it would dissolve into NH4 plus and Cl minus. All right, now if I introduce a base into the system, it's going to introduce OH into the system. OH is negative, so it's going to want to hook up with our ammonium here, which is positive. So what's going to happen is you'll have NH4, which is positive. You'll have OH minus. And what will happen here is one of those hydrogens will transfer from NH4 to OH, and it will form water. So you'll have NH3 with no charge, and you'll have H2O. So what's happening here, NH4 is being removed from the system. So its concentration is going down. Again, add, shift, away is the saying that we use for concentration. So the opposite effect is happening here. Instead of adding NH4 to the system, we're removing NH4 from the system. So we're going to shift to the right. And again, the right side is where we are dissolved in solution, or we've broken apart. So solubility will increase because we're shifting to the side of the reaction where everything is dissolved in solution. So solubility would increase in this case. So we've kind of hinted at this already, but this is explained by Le Chatelier's principle. If we introduce these ions, it's going to react with one of the ions from the salt. So if we're adding an acid, we're adding hydrogen. If we're adding a base, we're adding hydroxide. Those ions are going to react with ions from the salt, and equilibrium is going to shift to dissolve more salt to replace the ion that is being removed. Only weakly acidic or basic ions are affected by pH changes. Remember, strong acids and bases fully dissociate and don't participate in equilibrium shifts, so they completely disassociate into their ions. Because AP doesn't require any math for this portion of the test, you only need to predict the qualitative effect, being more or less soluble. So let's look at one last example here. So in this last example, we have calcium and fluorine, and we're adding HCl. So our reaction here is going to be calcium fluoride, CaF₂, solid. And that is dissolving into calcium plus 2, aqueous. And we're going to have 2 fluorines, aqueous. Okay, HCl is going to dissociate into hydrogen ions and chlorine ions, in this case, if we're adding HCl. So you have HCl, and it's going to dissociate into H plus and chlorine. So hydrogen is going to react with our fluorine here. So hydrogen's positive, fluorine is negative, so the concentration of our fluorine is going to go down because it is being sucked up by our hydrogen, and in order to replace that fluorine that's being taken out, equilibrium is going to shift to the right, and in doing so, this is going to increase solubility.